All right, so lesson 5 of unit 2, we're talking about box plots, okay? So you have your journals out, you have your notes out, and you put in your heights into our Google Sheets. So we've collected our data right on for us, okay? So those of us that have the data open, keep it open. We're gonna continue using it, okay, throughout the whole class. So if we take a look here, we have our objective and our essential concept. So our objective for the day is that you will learn how and when to use box plots to compare groups of data. You will also learn how to compute and interpret another measure of spread, the IQR, okay? So we're learning a few things today, guys. Number one, we're learning how to make a box plot. Okay, hidden in learning how to make a box plot, we're also going to be talking about how to find different values that go on the box plot, and we'll talk about that. So a lot of very important note taking today, guys. Then we're going to talk about the IQR, the interquartile range. Okay, this is another measure of spread, just like the MAD, the mean of absolute deviations. But I guarantee you it is much easier to calculate the IQR than it is the MAD, okay? Okay, our essential concept, the takeaway today. A common statistical question is, how does this group compare to that group? This is a hard question to answer when groups have lots of variability. When there's a lot of spread and variability in groups, it's kind of difficult to answer that question of comparing different groups, okay? One approach is to compare the centers, spreads, and shapes of the distributions. Box plots are a useful way of comparing distributions from different groups when all of the distributions are unimodal, meaning one hump, okay? So you can be unimodal and you can be symmetric, you can be unimodal and left skewed or right skewed, okay? Doesn't matter, right? Box plots are a great way of comparing different distributions and seeing how they're similar and how they're different. So box plots are another visual representation, okay? So far what we've seen before this lesson, we've talked about measures of spread, or I'm sorry, measures of center, the mean and the median, okay? And we're gonna be hitting on the median a lot today. We're gonna be using the median a lot today, okay? We talked about measures of spread, so the MAD, mean of absolute deviations. We learned how to calculate that. We learned how to make it on RStudio, all that. And then as far as graphing and visuals go, we've done dot plots. We've seen our data distribution in dot plots. We've seen them in histograms. And then today we're gonna add on with box plots, okay? All right, so today's focus is all of these tools help us describe data to someone who may not actually be viewing the actual data set. So I can describe data to someone using the mean, the median, with a visual representation, with using the MAD, right? And they don't even have to see the data set. Today, we're going to explore another way to summarize and describe data to others with the use of another type of statistical plot that involves breaking data up into distinct pieces, okay? And that's known as a box plot. Like I said, we're going to go through the process of making a box plot today. But first, what I want you guys to do is I want you to look at our spreadsheet, okay, where we just put our heights. And just by looking at the spreadsheet, just by looking at the heights in the spreadsheet, okay, do you think you can tell which of them represents the typical height of students in your class? How would you be able to tell? Remember, thus far, the word typical that we've been using, right, has been referring to center. So do you think that you can tell which of them represents the typical height of students in our class? How would you be able to tell? Okay. I want you guys to respond publicly in the chat to this question. And I'm going to share our table here in case you want to look at it. Okay, just in case you want to look at it here. Okay. And tell me, can you determine what the typical height is? Yes? Great. What do you think it is? No? How do you think, what do you think we might need to do to figure it out? Okay, somebody, why? Why did you determine that? How? Okay, guys, publicly, please. Okay. So far I got Samai and Alexander sharing with me privately, but they're sharing. Let's get other people's responses, please. What do we think? Can we determine the typical height? If not, well, what might we need to do? Right on, Janelle, thank you. Oh, Sarai, you said put it in order? Okay. You think that there is a typical height because you see the majority of students are in the 5-foot range. Okay, so you think the typical is in the 5-foot range. You'd have to find the mean. Only the mean, Katie? Will the mean only give us our typical? Or can we find something else that might give us a typical? Okay. Mean and median, Alexander, good. Yes, median as well, very good. But okay, so we can find both the mean and the median. Okay, I see that. I see that. Okay, great, guys, great job. Great job. Yes, find the mean and the median. So what do you think would be, someone mentioned it earlier, one person mentioned it earlier. What do you think I would need to do first in order to try to find the median and the mean? What's something I might need to do first? Put it in order, right? Put it in order. Thank you, Sarai. You were the one that said it from the beginning. Put it in order from smallest to largest, right? That might be something that might be helpful here. So if we go back to our PowerPoint, right, that's what we're going to do. We're going to go ahead and we're going to sort those heights, okay, so that they are in order from shortest to tallest. Oh, Dario, look at you coming through, okay? We're going to sort those heights. What I'm going to do is I'm going to sort it on our spreadsheet, and I want you guys to answer then the questions of how would you describe the distribution of heights? Okay, how would you describe that? Is there any trend that you are observing within those heights? So these questions are on your IDS journal, so I'm not going to project the PowerPoint. Instead, I'm going to project the spreadsheet in case some people are unable to view it. So what I'm going to do is I'm going to copy. Here's a little trick, guys. If you have a formula there, right, and you don't want the formula to copy, you just copy and you paste special and you paste values only. Okay, and then you can once again select all of this, right click, and sort range from smallest to largest, sort, and bulb-ium. Okay, there we go. Dario had it come through, but we can do that here. So here is your list of heights. Here's your order of heights from shortest to tallest. Okay, it looks like George is our tallest person in class. And who's 75 inches? Let's see. Oh, yep, there's, and then Alexis is right there with him. Interesting. So 2 minutes to answer your journal questions, guys. 2 minutes to answer your journal questions. Okay, so let's see if we can get some people to share their responses here. How would you describe the distribution of heights? And are you observing any trends? Would anyone, let's see, Dario, what would you say?
It's various numbers.
Say that one more time, hon.
They're various numbers.
They're various numbers, okay. And did you observe any trends?
They mostly begin with 60, so the median will most likely be 65.
Oh, interesting. Okay, so nice guess there. So we start in the 60s. They're mostly in the 60s. So you're guessing around 65. Okay, I like it. I like it. Um, okay, thank you, Dario. Let's see if we can get another person to contribute here. Kenya, what would you say, hon? Kenya, are you typing? You basically said the same thing Dario said, which was what, Kenya? Which was what? Recap it for us. Go ahead and recap it for us, yeah? Okay, there are various numbers between the 60s and the 70s, yes. So by various, are you guys indicating that there's variability in our data? Is that maybe something that you're thinking about, right? Yes, very good, yes. Okay, so yes, we see variability in our data, right? Most definitely. Okay, so let's take a look. We're gonna start the notes, notes portion here. Okay, so we have some beginning vocabulary to work with. We have some vocab that we want to understand. So 4 things that we want to understand, and 3 of them we've kind of heard of before. Okay, so we have the median, right? We should know that the median is the middle value, like smack dab middle, median, middle value of our data. Okay, and then of course we should be aware of minimum, right? The word minimum means the lowest value, the lowest possible value in our data. Maximum means the largest possible value in our data, so the largest value in our data. So we have the median, which is the middle, we have the minimum, and we have the maximum, right? And then we have something called quartiles. Quartiles. It stems from the word quarter or quart, right? And if you think about the word quart or quarter, hopefully the idea of like 4 parts or in forts or 25 cents or 25% comes into mind. And essentially, quartiles are sections that we break our data into, okay? And each section represents 25% of the data, okay? So quartiles is the value that ends every 25th percent of the data. Okay, so when we talk about a quartile, we're talking about the end of a section, right? And the value there, just like the median value represents the middle value, a quartile value represents the value at every 25th percent of your data. Okay, so why are we talking about quartiles? Because what we want to do is, in order to create a box plot, we need to break up our data into quartiles. And each value at each 25th percent of the data is a value that we're going to be putting on our box plot. Okay. So I'm going to give you guys another 30 seconds to get these definitions down in your notes. Okay. And if you need more than 30 seconds, please let me know. Okay. So to break things down a little bit more, in order to create a box plot, okay, what I need is I need the following. Okay. I need my minimum value. Okay. Oop, I don't want that to be in black. You can barely see that. Okay, you need your minimum value, right? Then you have your median, which is your middle value. Okay, that's your middle value. And then you have your maximum, that's your highest value, right? And then our quartiles, now from the minimum to the median, that represents 50%, right? Oops. What just happened? Oh, you guys, I'm so sorry. Ugh, so annoying. Okay, let's restart that. Right, so we have our minimum value, we have our median, and then we have our maximum value. So from our minimum to the median, the halfway mark in our data, that represents 50% of our data. And then the other 50% happens from the median to the maximum of our data. That's our other 50% of our data, right? So in order to break down into 25%, I then cut this, right? And this gives me my first quartile. So this is my first quartile value will be here, and that's going to represent, so 25% of my data will be here, 25% of my data will be there. And then I cut this again, I cut this one in half to get 25% here and 25% here. And this is going to represent another quartile value. Okay. So what we're going to do now is we're going to do this situation. We're going to break our data into 25% increments, okay, to create in our data to get something called a 5-number summary. Okay, the 5-number summary is your minimum, your maximum, your median, your first quartile, and your third quartile. So 1, 2, 3, 4, 5 numbers. Okay, so your 5-number summary is your min, your max, your median. Okay, and then with the first quartile, we call it Q1, and the third quartile, we call it Q3. Okay, and when we talk about our data, we'll talk about why there's no Q2, or it's not written Q2. And some of you guys already know from my FST days, okay? Some of you guys already know this information. So what we're gonna do here, what we're gonna do now, is we are going to go ahead and we're going to split our data, our distribution into the two groups. Okay, one half is gonna be the taller half of our heights, the other half will be the shorter half. Okay, so to decide which height represents our median height. So we're gonna go ahead and we're gonna find our median here, okay? We're gonna go ahead and we're gonna find our median. So what I wanna do is actually, I wanna share my screen. Okay, I wanna share my entire desktop with you guys. Because in sharing my desktop, I can do this, okay? I can do this with our data and we can work with our data right here, okay? So here is all of our data. So what we're gonna do is we're gonna go ahead and we're gonna find our median. That's the first thing we wanna do. Okay, we're gonna find our median. So to do that, I need to figure out how many data points I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I have 27 data points, okay? So what I'm gonna do is to find my median, I'm gonna cut that in half. 27 divided by 2 is equal to 13.5, okay? Which means that the 14th number, the 14th value is gonna be my median. Okay, so the 14th value is gonna be my median, right? Because we had 13.5, we go to the next whole number there. If I had a whole number when I divided, I would have to average, correct? So let's see, 14th number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Dang, Dario, right there on the head. Our median is 65. Okay, so our median is a 65 there. I'm going to go ahead and color that for us. There we go. The median is 65. Okay. So we went ahead and split our data. So the halfway value is 65. That means all of these values above 65, right, are shorter. So this is my the short half of my data. So the short 50% of my data. And then all of these are the taller half of our data, okay? So anything less than 65 is part of the shorter half. Anything above 65 is part of our taller half, okay? Dario, I hope you sent that privately. Oh, Dario. Okay, now, Dario just sent out a bunch of information. And half of you guys are like, what did he just give us? Okay. So, how do we then find our quartiles? Okay, how do we then find our quartiles? So the next thing we want to do is we want to identify the quartiles. What are the halfway marks now between each one of these halves? So what we do is we take those two halves and we split them again. So you're essentially finding the median of each of these halves. Okay, you're finding the median of the top half and you're finding the median of the bottom half. So in the top, each half should have the same number of values. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values in each half. So now I'm going to do 13 divided by 2. So same process as finding the median. Okay, that's going to be 6.5. Okay, that tells me that I'm looking at the 7th value. Okay, so from here, 7th value, that's 1, 2, 3, 4, 5, 6, 7. Okay, the 7th value in the top short half, that's going to be my quartile 1, my first quartile. Okay, so the 7th value in the first half of my data, that's going to be quartile 1. Then I come down to the second half of my data and I count again to the 7th value, but looking from only on the second half of my data. So 60, that's 1, 2, 3, 4, 5, 6, 7. Okay, so this here is now my quartile 3. That's my quartile 3. Okay, can anyone guess where quartile 2 is? Where's my quartile 2? Yes. Okay, my median is also my quartile 2. It's just another name for it. Okay, my median is also my quartile 2. And then, so we have 3 numbers down out of the 5-number summary. We have our quartile 1, or we have our median, we have our quartile 2, and then the maximum and the minimum, right? The minimum is our shortest value. Okay, so our smallest value is the minimum here. And we'll do that pink. And the tallest value is our maximum. Okay, and we will do that pink as well. So here is my 5-number summary. Okay, so what does this each mean? Let's pay attention. Okay, what does this information actually mean? Okay, so let's understand our quartiles here. Our quartiles, right, the breaks between each group are called quartiles. So this is my quartile 1 value, right? This is my median value. This is my quartile 3 value, right? Okay, so it breaks our data into 4 groups: group 1, group 2, group 3, group 4. Okay, the lower break represents that first quartile. So when it says lower break, it's talking about the low values of data. So the lower break represents our first quartile. So this right here is our first quartile, because 25% of our data, okay, 25% of the heights are shorter than this value right here. So when we say quartile 1, the quartile 1 value is 63 inches. we're saying that 25% of our data is shorter than 63 inches. 25% of the heights in our class are shorter than 63 inches. Okay, thanks, Val. That's what that means. So if the value of quartile 1 is 63 inches, we're saying 25% of our data is shorter than 63 inches. Okay, and then quartile 2, our median, right, that marks the halfway part. That marks 50%. So when we say our median is 65 inches, we're saying 50% of our data is shorter than 65 inches. That's what we're saying. 65%, or I'm sorry, 50% of our data is shorter than 65 inches. So how did we get 50%? We took this first 25% plus another 25% because that covers 50% at the halfway mark. When I move to quartile 3, okay, the upper quartile, the upper break, this now includes 75% of the data. So this quartile 3 value, 68 inches, this means that 75% of our data, right, because it's quartile 3, says 75% of our data is shorter than 68 inches. That's what that value is saying. When you get the Q3 value, you know that 75% of your data is less than that value. Okay. And then, of course, when you hit your maximum, which is also known as your quartile 4, okay, your maximum, obviously, 100% of your data, right, is going to be less than or equal to that amount because that's your maximum at that point. Okay. So how do we then take this information? How do we then take this information and turn it into a box plot? How do you draw a box plot? Okay, that's our main question here, right? How do we draw a box plot? We have our 5-number summary. Okay, we have our 5-number summary. Can someone, actually Dario already did it for us, right? Hold on, let me find Dario's share there. There we go. Yes, I'm gonna need that. Okay, because now I want to just share my PowerPoint here. Drop that down, bring this over here. Okay, so how do we then take our 5-number summary and draw a box plot, right? So let's see here. I'm going to go ahead and annotate. You guys ready? Because you're going to draw this with me. This should go in your notes. I know it says IDS journal, and that's great, and put it in your journal, but this should also go in your notes. Okay, so our 5-number summary. Okay, we have our minimum. Okay, our minimum is 60. And then we have our Q1, our quartile 1, that was 63. And then we have our median, that was 65. Our Q3, that was a 68. And finally, we have our maximum value. Our max is 76. Okay. So in order to draw a box plot, the first thing we need to do is create a number line. Okay. We need to create a number line. So we're going to go ahead and draw a line here. Okay, there's my number line. And you don't need to start your number line at 0. Okay, you don't need to start your number line at 0. You look at your minimum value. Your minimum value is 60. Look at that. That's a nice number. Okay, if it was like 62 or something, I'd probably still start at 60, right? You want to move in like nice increments. Okay, so since we are at 60 with my minimum, I'm going to start at 60. Why not? Okay, and then I'm going to go by 5s. So we go all the way up to 76. So I probably will go up to 80 because 75 and then 80, right? So I have 65, 70, 75, and 80. Okay, so 60, 65, 70, 75, 80. All right. Hold on, we got someone coming in here. There we go. All right. So from here, you want to mark each of these numbers on our number line. So I'm going to use a different color here. So minimum is 60. So I can start here. And what I'm going to do is I'm not going to mark a dot. I'm going to draw a line. Okay, I'm going to draw a line at 60. Q1, our quartile 1 is 63. So I'm going to draw a line at 63. So this is our minimum, right? Okay, that's our minimum. Q1 is at 63, so this is going to be 61, 62, 63. I could even mark them for myself if I really feel like it. Here we go. So I know exactly where 63 is. So here's 63. So this is your Q1, okay? Then my median is at 65. So 65 is right here. I'm going to draw a line right here at 65. Okay, this is my median. My Q3 is at 68. So 66, 67, 68, 69. So 68 is about here. Here's my Q3. And lastly, I have my maximum at 76. So 76 is right about here. So we'll do that. Okay. So you're like, Ms. K, this does not look like a box at all. What the heck you doing? Okay. So what you want to do is you want to mark, okay, the 5 numbers on the line. Mark the 5 numbers on the graph. Okay. Then you want to create a box using Q1, the median, and Q3. So create a box with Q1, the median, and Q3. So what do I mean by that? I mean, literally, take Q1, connect it to Q3, bring it over, connect it to Q1. The median stays in the middle of the box, right? Not the middle, but it stays inside the box. Okay. Lastly, you want to connect Q3 with the maximum and Q1 with the minimum. So what do I mean by that? I mean, you take from Q3, connect it to the maximum, Q1, connect it to the minimum. Okay. So this represents this right here from Q1 to Q3, right? Each of this represents 25% of our data. So this is 25%, this is 25%, this is 25%, and this right here is 25% of our data, right? So it shows us the spread, right? It shows us the spread on doing that entire, like for each 25% of our data. It's showing us that spread there for each of our 25% of our data. So this right here from Q1 to Q3 in that box, that represents 50% of our data, okay? So pretty much what this is telling us is that 50% of our data is between the values of 63 inches, okay, and 68 inches. It's saying 50% of the heights in our class are between 63 inches and 68 inches, Q1 and Q3. The shorter 25% of our data is between 60 inches and 63 inches. And then the higher 25% of our data is between 68 inches and 76 inches. Okay. Just draw it in your notes, David. Okay. So who needs time to draw this? Because we don't have a lot. And I was hoping you guys were drawing this as we were doing it. Okay. See if you, okay, you guys have a minute. That's it. 1 minute. Take a screenshot if you need to, guys. Take a screenshot if you need to, okay? I wish I could give you more time. I honestly do. Here, let me actually take a screenshot too. Yeah, Dario, later. Okay. So, unfortunately, I am going to move on. Okay, I do want to move on because we do have a bit more to talk about before we get to our activity for today. And I want to give you guys enough time to get that done. And as you can tell, I'm stalling so people can keep writing. Okay, and someone is unmuted, guys. Or was unmuted. Here we go. Okay. And we're going to go ahead and clear the drawings. Okay. And let me share just my PowerPoint at this point. Okay. So what we need to understand is we need to understand some of the information that our box plot can give us. Okay. So in this part, it says the difference between the largest and the smallest heights, or the maximum minus the minimum, is the range of the data. Okay. So one way to talk about the variability, not necessarily variability, but one way to talk about how extensively our data varies, right, is to speak about the range. And in order to find the range in your data, we simply, we simply just take our maximum and we subtract our minimum. So to find the range, it is simply just maximum minus the minimum. So what that does is it tells you how, it tells you the distance between your maximum and your minimum, right? It tells you the distance between your maximum and your minimum. That's your range. It's the distance between your highest and your lowest values. Okay. Similarly to range, though, you can calculate your quartile 3, your quartile 3 minus your quartile 1, okay, which gives you 50% or half of your data, right? As I was talking about in the box plot, right? Q1 to Q3 represents 50% of your data. Okay. So when you do Q3 minus Q1, it gives you the range of your middle 50% of your data. This difference is known as the interquartile range, your IQR. So in order to find the IQR, okay, in order to find your IQR, okay, all you have to do is take your quartile 3 value and subtract your quartile 1 value. So the IQR is essentially the range of your middle 50% of data. The range of your data is the range of your total data, of the 100% of your data. Okay. So knowing this information, I want you to answer the following questions in your IDS journal. Okay. Using the box plot that we just created in class. It says, in inches, what is the difference between the largest and the smallest heights? Is there a large difference between the tallest and the shortest person? Okay, and then in inches, what is the difference between the quartiles of Q1 and Q3? We know that 100% of our distribution, the students, falls within the minimum and the maximum heights. But what percent of your distribution falls within these two values, right? And this question right here is kind of already answered to you in this bit, but I just want you guys to put it and summarize it there in your journal, okay? So make sure you get this down for notes, this bit right here, and then answer your questions in your journal. I'm going to give you guys 3 minutes to do this. Okay, 3 minutes. Okay, great discussion, guys. Great discussion. I just forgot to record it. But good job. So what we've seen this far, right? Measures of center. So we didn't learn any new measures of center. We're still on mean and median. However, for measures of spread, we've added on, right? In addition to the MAD, the mean of absolute deviations that deals with the mean values, right? We now have the IQR, which tells us the middle 50% of our data using the median and quartiles. And then as far as graphing and visuals go, we've added on box plots, right? We've added on box plots. So I have a question for you. Let's summarize this information about IQR, okay? The question is this: what does it mean when the IQR is small? Highlight one of the underlined phrases below. So when the IQR is small, does it mean that the middle 50% of heights are close to each other or spread out from each other? What does it mean when the IQR is large? Does it mean that the middle 50% of heights are close to each other or spread out from each other? Okay, this is just highlighting. So I'm going to give you guys a minute to do this. Okay, just 1 minute to complete these statements in your journal. Okay. Okay, we have 10 more seconds. Oh, damn it. Sorry about that. Just a lot of technical issues on my end today. The IQR is the interquartile range. Interquartile range. Q3 minus Q1. Okay, so what do you guys think? Let me see it in the chat. Okay, let me see it in the chat. What does it mean when the IQR is small? Okay, what does it mean when the IQR is small? Does it mean that the middle 50% of heights are close to or spread out from each other? Okay, yes, 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 yes. When our IQR is small, yes, absolutely. It means that our middle 50% of heights are close to each other, right? Just like our IQR for our data was 5. That means most of our middle 50% of heights are very close to each other. They're within 5 inches of each other. And when the IQR is large, then obviously it means that they are spread out from each other. Yes, okay? So it means that we have more of a variability among the middle 50% of our data, okay? So very good. So when it's small, our middle 50% is close to each other. When the IQR is large, our middle 50% of heights are spread out from each other. Very good, guys. Very, very good, okay? So what this means is that this actually brings us to our 2.5B assignment. A is your homework. Yes, I'm giving you homework today. Please don't hate me, okay? A is 2.5. A is your homework. 2.5B is your classwork. Okay, I have gone ahead and subset our distribution into females and males. You will create a box plot of heights for each on a piece of paper, okay, using the techniques that you just learned in class today. So just a quick recap. I know this is taking a while and it's taking away from your time on the assignment. But if you need a recap on how to create your box plot, okay, you have your number line that you create, whatever the numbers are, right? You create your number line. Usually people move in like increments of 5 on number lines, okay? But either way, you're gonna be putting in 5 lines based on the information that you gather from your data, okay? These two at the ends, this is gonna be your minimum on the low end, your maximum on the high end, okay? Depending on your data, these lines might be really close together. They might be more spread out. Some might be closer, some might be spread out. It really depends on your data, right? So minimum and maximum are on the 2 ends. And then the 3 here in between, okay, you have your Q1, you have your median, and your Q3. Okay, you create the box using your Q1 to your Q3. So this is literally your IQR. Okay, right here. And then from Q3 to the maximum, you draw a line through the middle. Q1 to the minimum, you draw a line through the middle. This is your box plot. Okay. Guys, refresh the assignment. It should be published and you should be allowed to access it now. Okay. It was locked. No, you're doing 2.5B right now, Janelle. Okay, you're going to do 2.5B right now. And you should be able to access it now. I have published it. So you might want to refresh the page. The reason why it was not published, that was on purpose, okay? The reason why it was not published is because I wanted to put in your specific data. Okay, so this data is your specific class data. So I wanted to have that data so I could put it in, and then I published it because I know you guys. If I had published it, you guys would have made a copy and then you would not have had the right data, okay? So refresh the page, click on it, you should be able to access it. You are going to make a female box plot and a male box plot. You're gonna answer, you're gonna find the IQR, you're gonna answer. For the box plots, you can do them by hand and then take a picture and upload that to the document before you submit it, okay? And then you have your 2.5A. Your 2.5A is your homework, ladies and gentlemen. Am I sharing? I'm not even sharing this, y'all. Okay, so 2.5B is very straightforward. Draw your box plots, find the IQRs, compare them. 2.5A, it's the reverse. The box plots are drawn for you. You are pulling information from them, okay? So my FST kids, I know you're in here, okay? My FST kids, what are these little asterisks? What are these asterisks right here? Okay, yes, Dario. Listen to Dario. Okay, thank you, Ishmael. Yes, Maddie. These little asterisks are the outliers, okay? Which means that they did not fit into the pattern of the data. But you need to be careful because when you have outliers, this right here does not end up being your maximum or your minimum, okay? This end does not end up being your maximum or your minimum. The asterisks are considered, in this case, these are higher, so we're talking maximums. So your maximum here and your maximum here for actors and actresses, okay? No, you should count them, okay? You should count them. So you're gonna answer these questions for your homework, ladies and gentlemen, okay? They're very straightforward. You're pulling your 5 numbers from the box plots themselves. So you're working reverse here and then answering 2 questions about them. That's it, okay? Both assignments together shouldn't take you longer than like 30 minutes. Okay, all right, we have a good 12 minutes left to class. So I'm going to allow you guys to begin working on 2.5B, okay? Work on 2.5B, ask questions. If you need a recap on how to create a box plot or find the quartiles, please ask, okay? I'm waiting for your questions.